So now we're going to start seeing multiple triangles within the big triangle. Yesterday we talked about a few things. Can you use sine law for right triangles? Does sine law work with right triangles? Gianna is saying yes, and it does. Sine law works for any triangle that you can find a pair with. If you find the pair, sine law is the way to go. Okay. We ended up finding the height of that tree. Okay. So the height, remember, is always measured at a 90-degree with the very top of that item, okay, the object. So we need to make sure we cut a right triangle out of it. So when you look at this top here, we took this side, correct? The right side. Could we have worked with the left side? You think? Just think about it logically speaking here. The height of something doesn't change whether I look at it from this side or whether I look at it from this side. The height of that thing stays the same, right? So what do you think? If we had worked with this side, we better arrive with the same final answer, correct? I chose to go with this one. Let's try that one as well. I need you to see it, right? Because if you just hear me say it, you're gonna forget tomorrow or the next day. So let's go ahead and thing is I used up all the space. So what we're gonna do is we're gonna use this chunk right here on page 265. Okay, do you have room there? I hope so. Finding height version 2.0. How's that? Jets 2.0, right? Trying to make that work. So I'm gonna go back to this one and cut it like this. I'm gonna use that one. So boom, I cut it and I make it look like this. There's my right angle because the height is always measured perpendicular to the ground. Do you remember that word? Perpendicular? 90 degrees, yeah. So what do we know about this triangle here? We know the 32, right? We know can we use 30? Technically this dashed line is cutting it, right? We cannot use the 30. But did I give you enough information there? This here? But that's not part of this triangle, right? Because we're cutting it right here. I didn't give you enough information. Hold on. Take a moment. Take a deep breath. I'm just going to see if I can give you that answer. Yeah, I could just give you this number, but that right now defeats the purpose. Yeah, you could. Yeah. You know what I'm just contemplating right now? I don't want to make this too busy and then you're going to get all confused. So, no, we're not going to find the height 2.0. Sorry about that, guys. I was getting too excited. It is possible, but not with the room we have. Okay? Moving on. Shake it off. Sorry, guys. You are in somewhat good hands, but not always. Here we go. Let's look at this this scenario right here. A communication tower is stabilized by guy wires. You know what those are? When you go the hydro poles that have the wire with a yellow wrap around it, so you don't cut your head off when you walk against it. Yeah, those are right here. They're supporting this tower. One wire is 3.7 meters long, which is right here. A second guy wire is attached to the pole 1.2 meters, 1.25 meters higher than the first one. So that's this number right here. Right, so the second, so you can make big dots there. I like to kind of see like that's where they're anchored. And they're both connecting to the same point on the ground. Okay. The angle made between the two wires is 10 degrees. Can you call this angle of elevation? The 10? Why not? There's no horizontal. There you go. So you are listening. What is the length of the second wire? So they're asking for this. Let's call it something. I'm going to call it Y. Okay? Let's call that Y. Do you see a pair in that triangle? It's hard to see, right? But this side right here is across this angle right here. It's a thin one, right? But this is nonetheless, it's a pair. So again, this is going to change, right? Pair, use sine law. This is going to change very soon. Okay? I have to use sine law. So here we go. The rest is kind of, you know how to do, right? So we're going to go sine of 10 degrees over 1.25. meters. And then you have to ask yourself, so I always want to start with a pair. Okay, that's my pair. I'm going to highlight it, right? What else can you solve for? Can you, in order to find this side, you need this angle, correct? Is it possible, like they're both unknown? They're both unknown. Don't touch them just yet. But this 3.7 meters is across what? This 3.7 is across this angle right here. That is another pair. You see that? Let's call this A. So sine A is going to be over 3.7 meters. So basically what I just realized, like I can't, this is not a slam dunk question. This is a two-step question, right? Write that down right next to it. You realize just now that you can't answer it in one calculation. You're going to have to do multiple calculations. So let's go ahead and find sine A is cross multiply and divide 3.7 sine of 10 over 1.25. And I like to just put the number right beside it, and it better start with a 0 or else you made a mistake. Or we made a mistake, right? Because I do make mistakes, right? Yeah, you're well aware of that. 5, 1, 3, right? So that would be your second line. And then the third, and the reason I'm doing this is because cosine law is going to be about the same. So that I want you to just remember that. It's like, okay, sine of A is this, which is that. And so the next line is A is sine inverse of just this. And so let's go ahead and find it. I'm leaving it on my screen here. Second sine equals. That's 30.93 degrees. But that's not the answer, so I'm just going to underline because it is important to me. Let's call, because my goal here is to find this angle, which I just did. When you have two angles, you can find a third one and then find that side. Let's call this what? I will call this capital Y. So capital Y is 180 minus the 10 minus 30.93. So that is 170 minus 30.93. That gives me 139.07 degrees. It's not the final answer, but it's very important to me. So step one, I guess there's an intermediate step. Now I'm going to go back to, I'm going to use the pair. Look carefully. I'm going to use the pair that I used the first time because that one is given to me. I'm guaranteed to have that part right. And now I'm going to use sine of 139.07, right? That angle I just found here, which is going to find me side y. And I will highlight this again. Okay. To make sure you understand, cross multiply and divide. In this case, you're solving for a side, okay? So you go 1.25 times sine of 139.07 divided by sine of 10. I encourage you to type this in as I'm talking here. That's why I'm actually doing the same with you. And that is 4.72. And we are in meters, right? Hold it. Before you move on to the next question, you want to double check. Is the longest side across from the largest angle? So which one is my longest side right now based on the numbers? Yeah, and it is across the largest angle, right? So it's a little check you can do, because if that's not happening, you made a mistake. But there's a chance that you're going to get a math error anyways before you get to that point, but still check. So I'm going to do this. I'm going to box this part in. Okay, I'm going to call this step 2. And then I will box in this top part. That was my step 1. And by that I mean like sine law had to be done twice. Okay. Do you have a third highlighter? If you do, I'm just going to show you that this number right here made its way into my second step, right? Like I had to take that angle, the third angle, to find that missing side. So sometimes I kind of say just start solving for stuff you know, right? Or you can solve for, and then everything else will kind of fall into place. So does sine law work with obtuse angles? Obviously it does, right? It does work. Okay, next page. Go to the next page, please. And then I want you to give it a go. Because just listening to me is just not fun, right? Go ahead. So give this a try. Read it. You technically know everything you need to solve that one. Try it first before you do anything else. Read it, highlight, identify, all those things. Okay? And I will go over it. No, I don't want to break anything. Okay, so let's dive in here before we go. Okay, this is going to be the last thing we do. So make sure you have highlighters. How far is cat from Pika, right? So that's this here. Okay, let's call that something. Let's call it X. Okay. Question: can you split this triangle in half? Can you split it? It's asymmetric, meaning how do you know something is asymmetric? Well, the diagram kind of looks asymmetric, but do you notice that this is 17, that's 36? If those had been exactly the same, go for it. Cut it in half. You have you can split the 20 in half. But if these two aren't the same, right, you can't do that. So I'm going to use the whole thing, okay? So how far is cat from Pika? So you're wondering, where's my pair? Hidden. Look for the hidden pair. Look for it, okay? Where is it, Mr. Dirksen? It's right here. This whole thing. Let's put an arrow out. 180 minus 17 minus 36. And what do I get there? 127, yes. So I'm going to use a red pen and say that this is 127. And I'm going to write it in 127. The whole thing from end to end is 127. So what's that dashed line doing there, Mr. Dirksen? It's trying to get you to fall for it, to get confused. Okay, so 127 matches this. That is my pair. Okay, hidden pair right there. That's the highlight of the day. All right, sine of 127 over 20. And which angle am I going to use? I'm going to use 36. Forget about the dashed line right now. Forget about it. Okay, 36 is across x. So sine of 36 over x like that. X is equal to cross multiply and divide. Okay, you're not solving for an angle, you're solving for a side. And when you compute that, I will just give you the answer. It's 14.72 meters. Okay, so there you have it. This pair was hidden. You had enough. So I would always suggest work with the big triangle first. Okay, the big one outside. Okay, next. How far is Steve from Pika? So take another highlighter if you want. Right, that's the one they're after. What are we going to call that? Y. Okay, we're going to call that Y. Can I use the same pair? Go for it. Once you have it, you have it. And now I'm going to use sine of what? Sine of 17 because that's across Y. There we go. I know if you pay attention, you can do this. Okay, I know it. I've done this enough times. Students all over the city have watched me do this, and they were successful as long as they pay attention. Okay. Y is 7.32 meters. Does it make sense? The angle across this side is smaller than the other one, correct? So it makes sense. Okay. Next, this is the grand finale here. I need you to try a couple for tomorrow's AC. Okay. I will have one there waiting for you whether I'm here or not. Okay. What we're gonna do here, watch. The width of the creek is like finding height. Okay. It's like finding the height. So we're gonna do this. I'm gonna cut it here and make it a 90. What's our time like? We still have 5 minutes. Relax. Everybody relax. This is 17, right? This is the width. And do I know anything else? You're like, yeah, Mr. Dirksen, I know 20. 20 right here. No, that's not 20. You cut the 20. Do you know this one? Remember, I used green, right? So that's the green side you found up there. What is it? 1472. Right? Do I have a pair? Can I use that pair up there, Mr. Dirksen, the one you used earlier? Can I use this one? Or this one? You're dealing with a new triangle. You're dealing with a new triangle, so don't use it, okay? So I need to use sine of 90. Anybody remember what sine of 90 is? Oh my goodness, you guys, listen. Sine of 17, which is this one over W. So it's 14.72 sine of 17 over sine of 90, which we all know is 1. So you don't really need to do that. You don't need to type it in. It's just 1472 times sine of 17. That is 4.30 meters. Okay? 4.30 meters. Okay, hold on. Homework. I want you to try page 268 and 270. Page 268 and 270. You want the answers? I'm going to give them to you now. I will not post them. I will just write them on here. Okay, so ready? This is going to be on the video anyway. So 268, if you go to this one, hold on. I'm trying to find it. I don't think I have the answers to that one, but 270 I do for sure. So go to 270. 270, question 8 is 74.49 degrees. And question 9, for A, it's 48.63 degrees. And for B, which leads to the next page, it's 3.53 meters. Okay, so do at least page 270 because I didn't give you the answer to 268 for tomorrow. Okay, guys, thank you.